Good morning everyone. Today we will solve some problems from the textbook, that is in first module, that is 2.1 problem we are solving. So that is I will read the question first, please listen carefully. A drive has the following parameters. The torque is given as 150 minus 0.1 Newton meter, where n is the speed in RPM. So here torque is given 150 minus 0.1 n. N indicates the speed in RPM. And the load torque TL is equals to 100 Newton meter. Initially the drive is operating in steady state. The characteristics of the load torque are changed to TL equals to minus 100 Newton meter. Calculate the initial and final equilibrium speeds. He gave us the torque of the motor and the load torques, and he's asking us to find out the equilibrium point speeds. So the condition here given is at steady state. So this is the important point you have to note, at steady state. So here the motor torque T equals to 150 minus 0.1 n Newton meter and TL is 100 Newton meter. At steady state we know the torque T equals to TL, motor torque equals to load torque at steady state condition. So equating this condition, so 150 minus 0.1 n equals to 100. From this minus 0.1 equals to 100 minus 150, you will get 50 here, and minus minus gets cancels. So 0.1 n equals to 50. So what happens from this, I will get n as 500 RPM. So this is nothing but initial equilibrium speed. After the load torque has changed, characteristics are changed from TL is equal to minus 100. In the same way, at steady state again we have to calculate this value as T equals to TL. This is at a steady state. That's why they are asking it as a equilibrium position at steady state. So T equals to TL. Again 150 minus 0.1 n is equals to minus 100. Right. So from this minus 0.1 n equals to minus 250. Right. So from this n is equals to 250 minus 0.1, then you will get 250 2500. This is the speed at the final speed. Okay, this is the final speed. So similarly we will do one more problem, that is this problem is previous university question paper problem, that is asked in July 2019. So see the question. A drive has the following parameters, that is J equals to 100 kg per meter square and T equals to 100 minus 0.1 n Newton meter, and where n is again is given is a speed in RPM, and the positive load torque TL is equals to 0.05 Newton 0.05 n, that is Newton meter, and it is also operating at steady state, and he is asking you to find out reverse if the load torque is reversed to the minus 100 minus 0.1 n, and is asking you to find out the time of reversal. Okay, he is asking you to find out the time of reversal. So for this problem, same condition we have to consider, that is at steady state. This is the most important point you have to remember, that in all the problems, in almost all problems, this steady state condition is considered, and we are going to solve the problems. So these problems are very easy. Let us solve this problem. So for steady state, as you know, at steady state, what is that? Motor torque is equals to load torque, right? So under this condition, what I am taking this motor torque, which is given as 100 minus 0.1 n, should be equals to load torque TL is equal to 0.05 n. So that I am considering. So I will get 100 minus 0.1 n minus 0.05 n is equals to 0. Okay, so I'm making T minus TL is equal to 0. In this way I am writing the value. From this, what is the that 0.15 n is equals to 100, and from this I get the speed of 666.7 rpm. Okay, so what happens now? I got the speed n in rpm at steady state at the starting point. So later on at the initial drive point. Next, what I have to find out? I have to find out the after reversal, what is the speed. So after reversal for steady state, after reversal the steady state speed, that load is passive load. Okay, the load is passive load, that is I'll get minus 100 minus 0.1 n minus 0.05 Newton equal to 0, n equal to 0. From this, if I calculate n, I'll get minus 660.7 rpm I'll get. Okay, so simple. This one, equate the n terms and get the value of n. So this, as we know, the n is given in rpm. Now what we have to find out means, we have to find out when reversed, under reverse condition, we have to find out the timing. So we'll get this from the equation, that is j equal to d omega m by dt is equals to minus 100 minus 0.1 n minus 0.05 n. So this condition, what is this formula? From where we'll get this formula? From when reverse, what is happening? J d omega m by dt is equals to t minus tl. Okay, so from this formula condition, we have to write this. So where j omega is nothing but radians per second. So but we know the speed is in Newton, that is in rpm. So from radians to rpm, if you convert, you will get j into d into 2 pi n by 60 into dt is equals to t minus tl you will get. So from that, if you take dn by dt, you will get this as 30 divided by j pi into minus 100 minus 0.15 Newton. So if I solve this further, so what I will get, this j is nothing but 10. So if I take 10 times it cancels. So 3 by pi I will get. So 3 by pi value is 95.95. So which I will multiply with this 100. I will get minus 95.4 minus 0.143 Newton I will get. Okay. So this is nothing but dn by dt value. Okay, so from this, what I have to do? I have to find out the value of t value. So from that equation, I can get the t value as, so t equals to integral of dt, where that is from here. If I remove the value of dt, what will be the dt? Dt value will be dn by minus 95.4 minus 0.143 Newton. Okay, so this condition, this formula I am taking here. So the speed from n1 to n2, I am applying the limits, that is dt I got from there. Dn is equal to minus 95.49 minus 0.143 n. So what I will do in this, I will make this as a common. I will take minus this one, so that my equation should come into the form of integral 1 by ax plus b into dx, where the answer is 1 by a into ln ax plus b. In this form I have to get. So what I will do, I will take this as out. So I will get here minus, I will take minus 0.143 common. So if I take 0.143 minus 0.143, I will get an integral n1 to n2 dn. I will get here n plus 667.7. If I take the common this one. So from this, so I know the speeds. The speed is n1 is 666.7 and n2 is my minus the n2 speed is what I have to take n2 is what happens, the speed will change, because from motor to the load side, what happens, there is a change in the speed because of the efficiency. So I'll take 0.95% of efficiency. So I'll take minus 666.7 into 0.95. So this speed I will get is minus 633.4 RPM. Okay, so 95% of efficiency I am taking. So I have to multiply this N1 speed with this 0.95, so that I will get minus 633.4 RPM. Okay, so with this, applying these limits in this formula, so what I will get, this minus 1 by 0.143, I can write it as minus 7. Okay, so the integral of this 1 by n plus d n plus 667.7 will be ln n plus 667.7 over the limits n1 to n2. Okay, let me apply the limits. Minus 7 ln, so L1 I am taking as N1 I am taking N1, first I am taking N2, that N2 is minus 633, so minus 633.4 plus 666.7 minus ln 666.7 plus 666.7. So this I will get minus 7 into ln 34.30 minus ln into 1334.46. If I add these two, I will get this much. So minus 7, then ln of this is log a minus b, so that is log a by b, so I will get 34.30 divided by 133.4.4. So this value will get minus 7. So ln of 34.3 by 1334, I will get ln 0.0258. So this, if I apply in the calc, I will get this, multiply with minus 7, I will get the t value as 25.596. Okay, so this is the time. Is asking to find out the time. So time of reversal. So the two things you have to be in